Ever wondered what powers your smartphone, your computer, or even your car? The answer lies in a tiny yet mighty silicon structure, a microchip. But how does this tiny speck transform into a technological marvel? Picture this: you're using an array of gadgets every day. You're texting on your smartphone, binge-watching your favorite series on your smart TV, or even microwaving popcorn for a late-night snack. Behind every press, click, and beep is an unsung hero, the microchip. This tiny powerhouse, no bigger than a grain of rice, is the heart of modern technology. It's the brain behind your devices, orchestrating a symphony of zeros and ones, binary codes that bring your tech to life. From the alarm clock that wakes you up to the car that takes you places, microchips are the invisible conductors of our digital orchestra. They're the tiny wizards making our tech-saturated lives possible. To appreciate the microchip's magic, let's dive into the intricate process of how they're made. Believe it or not, the journey of a microchip begins with sand. Yes, you heard that right, the same stuff that gets in your shoes at the beach is the raw material for the brain of your smartphone. But we're not talking about just any sand, we're talking about high-quality quartz sand, which is rich in silicon dioxide. This silicon dioxide is put through an intense purification process, removing impurities down to the parts per billion level. Imagine trying to find 1 grain of sand in an Olympic-sized swimming pool. That's the level of purity we're talking about. Once purified, the silicon is melted at temperatures hotter than the surface of the sun and then formed into cylindrical ingots, much like a silicon sausage roll. These ingots are the building blocks for our microchips. So the next time you're at the beach, remember, you're standing on a potential goldmine of microchips. Now that we have our silicon ingots, it's time to slice and dice. Imagine a chef, but instead of a kitchen knife, they're wielding a diamond-edged saw. The silicon ingots are carefully sliced into thin wafers, about as thick as a human hair. This process is a fine balance between delicacy and precision. One wrong move and the wafer could shatter, rendering all our previous work useless. This isn't some slapdash operation. It's a meticulous dance, a ballet of technology, if you will. The ingots are placed onto the saw, and the slicing begins. It's like cutting into a loaf of the most precious bread in existence. Only this bread can power your smartphone or laptop. These wafers are the canvases upon which we'll paint our electronic masterpiece. The precision involved in this step is crucial. Without the wafer's integrity, the whole process falls apart. So, it's safe to say that the pressure is on. It's not your typical kitchen slicing and dicing, is it? Now, onto the artistic part, where our silicon wafer becomes a canvas. The magic of etching begins here. It's like tattooing, but instead of ink, we use light and chemicals, and our canvas is a silicon wafer, not skin. First, a layer of photoresist, a light-sensitive material, is applied to the wafer. Then it's baked, but don't get too excited, it's not the kind of baking you're thinking of. This baking solidifies the photoresist and preps it for the next step. Next, the circuit design is projected onto the wafer using ultraviolet light. It's like a movie premiere, but for circuits. The exposed areas harden while the unexposed areas remain soft and are washed away. Then, chemicals are used to etch away the exposed silicon areas, creating the intricate labyrinth-like patterns that make up the microchip. It's a microscopic masterpiece, a silicon Sistine Chapel, if you will. One could argue that making microchips is a form of high-tech art. With our design etched in, we're nearly at the finish line. Now comes the final sprint, where our microchip gets its unique characteristics. This process, known as doping, introduces impurities to alter the silicon's properties, giving it the ability to control electrical current. It's a bit like adding spices to a dish, giving it that extra zing. Next, we layer on the metal. Think of it as icing on our silicon cake. These metal layers form the connecting highways between different components of the chip. Finally, the chip is packaged, protecting it from the outside world, and preparing it for its journey into your favorite device. In essence, the microchip manufacturing process is a symphony of precision, innovation, and a dash of silicon magic. From humble sand to intricate silicon wafers, through slicing, etching, doping, and packaging, each step is crucial to creating the tiny powerhouse at the heart of modern technology. So, next time you use your smartphone, spare a thought for the tiny chip that makes it all possible. It's gone through quite a journey, from a grain of sand to the heart of your device. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Thank you for watching Origin Opus YouTube channel.